Oasis Network is a privacy-focused smart contract platform for open finance built using the Cosmos SDK. The project prioritizes applications and use cases that promote data privacy and user confidentiality. It aims to achieve this goal by separating its consensus layer from its contract execution layer while providing a built-in interface connecting the two for privacy-preserving computation. The consensus layer acts as a hub that uses a proof-of-stake (POS) mechanism to secure the network and reach a consensus on transaction validity. The execution layer consists of multiple, parallel runtimes, called ParaTimes, for specialized computation needs that each plug into the consensus layer. The Layer 2 scaling solutions have evolved from sidechains to commit chains, rollups, and validating bridges. Rollup refers to running a smart contract virtual machine where the virtual machine state is periodically verified and committed to an underlying blockchain to provide smart contract functionality at a reduced cost and a higher throughput rate, as opposed to running smart contracts directly on the underlying blockchain. Verification done at the underlying blockchain secures the state transitions, and the off-chain computation allows smart contract execution to scale. We didn't call them rollups, but that's how Oasis Network's ParaTimes or compute layer works. From its inception, the Oasis Network has separated computation from consensus as a modular design principle. This separation means that ParaTime layer entities only handle smart contract execution, and the consensus layer entities only handle consensus, and both are greatly simplified. This has many benefits, including ease of auditing, fault isolation, and reduced compute replication without sacrificing security. The separation, having compute done in a rollup virtual machine and the results verified and logged into a blockchain, is exactly what rollups are all about. The Oasis Network isn't just a network that natively supports rollups. The architecture is optimized for rollups and only rollups. It discourages putting general computation in the consensus layer, and allows only built-in contracts to run there. These built-in contracts are the validating bridge contracts in rollup parlance. While the Oasis architecture design goals were for a modular Layer 1 blockchain that supports smart contracts, one might argue that the result of the modularity is that the Oasis consensus layer is a blockchain that only supports rollups, since viewed through the rollup lens, all ParaTimes are Layer 2 rollup virtual machines. In particular, Oasis's validating bridge in the consensus layer uses a fraud-proof technique called discrepancy detection to validate the results from the compute layer. This technique, resulting from fraud detection and system architecture co-design, uses bare metal proofs that are simple and thus more trustworthy since there are fewer things to go wrong. As we will see, the simplicity of bare metal proofs also gives ParaTime designers more headroom, implementing a smart contract execution environment where smart contracts are sandbox native code becomes feasible, giving the system headroom for performance improvements beyond that of concurrent ParaTime execution. Rollups have mainly been designed to speed up Ethereum smart contract processing. More specifically, they were designed to execute Ethereum smart contracts, but in a separate, independent virtual machine, distinct from the Ethereum virtual machine (EVM) on the Ethereum Layer 1 base chain, to reduce the Layer 1 workload. All of the real contract execution is done in the Layer 2 rollup virtual machine. The only work that the underlying blockchain does is to validate the rollup virtual machine execution using a validating bridge smart contract. Normally, the rollup virtual machine is also an instance of the EVM, and in some designs, example, Arbitrum, the rollup virtual machine is tweaked to make validation in the base chain easier. As long as the validation check in Layer 1 is cheaper than running the rollup smart contracts directly in Layer 1, we have an efficiency gain since Layer 2 machine execution is supposed to be cheaper.